Oh, hi! It's great that you joined me today. My name is Viktor Gamov and welcome to Livestreams, a weekly show where I'm talking about all things stream processing, cloud, Kafka Streams, Kafka, streaming tools, and all things that you folks would be interested to learn. I'm willing to share. Welcome, 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 welcome. It's great to be here. It's great to be back. I took some time to relax during some of the holiday season, plus some of the other work that I was doing. I have to finish it. So yeah, but it's good to be back. It's good to have all of you right now. So based on my notes, I see right now notes. Based on my information, I have 14 people right now. It's great. It's great that we have some people join. So as always, if you're first timer here, write down in the comments where are you coming from. It would be great to learn a geography of our show. Where the people coming from, what's your town and what's your country. And to make it a little bit more like fun, maybe write down also like if you drinking something cool today. I did not prepare for my show as I usually do, so I don't have any drinks today, but hopefully you folks are hydrated and you do have some cool stuff here. All right, so let's see. Let's see our comments here. That's a very good question. What's going to be topic today? I'm going to be talking about in a moment. We will reveal all the topic information very, very soon. All right. And Marcel coming to us from Berlin. Welcome from Berlin. It's great that our scheduled time works for folks in Europe that we were trying to do. Surav from Oklahoma. Welcome to Livestreams. It's great to have you here. What kind of jacket I'm wearing? I'm wearing today jacket from Noble. It's some sporting brand. You can Google it. It says Noble. It's very light and I like it. Yeah. Thanks for that. Rajesh from India. That's great. Welcome. Also the time zone wise, it looks like my scheduling works for folks in Asia. Anand from Houston, Texas. Amazing. Robert Cross. Just finished the team presentation on KSQLDB on Kubernetes. Wow, that's great. Robert, I need to invite you here so you can also present this. That's a great topic and I would love to hear more about this, or maybe we can crack this in one of the live streams in the future. Shri Krishna from Brussels, welcome. Come on, that's not about the quality of presentation, it's about the content, right? So if you will be able to run this some cool technology like KSQL and Kubernetes, I would love to learn this. Yeah, we can work on the presentation, so that's not a big deal. Narinder from Sweden, welcome. Yeah, we expanding our geography. We have Narinder, Julius, I guess it's a town in Sweden. Wow. So I've seen this in one of the live streams, the people that I follow. There's a guy, Aaron from Okta. He's also doing live streams. And what he's doing, he's actually putting a map of when the people join, the map automatically will light out. I need to see if I can plug the Kafka there so I can talk about this demo during, showing the map where the people coming from. Mark from St. Petersburg, Russia. All things Kafka. Здравствуйте. That's great that you join us. Maximiliano from Argentina. Great. And the people keep coming. So, folks, thank you for joining. So, let's talk some business. So, if you've been here for a while, I see some of the regulars. For example, I see Raspergu. He's not the first timer here, and he knows that I like to talk about Kafka Streams, and yeah, that's what we're going to be talking about a little bit. And if you've seen the last live stream, I personally experienced some of the technical difficulties during this live stream. Some of the things happened that were beyond of my control, and apparently it was affecting some of the audio quality of the previous live stream. So we decided to scrap it because we, don't like you folks having like a crappy experience on listening our audio or our videos and things like that. So I will do quick recap of the things that I've done last time. And last time I was talking about more stateful Kafka Streams application where I'm run those on Kubernetes, how to enable this, how to run this, how to see if thing is actually working, and so far and so on. So we will talk about this. Also, I would like to do some announcements in terms of what is going on with the channel, where we're going, what's going to be the next cool things, and also some of the learning opportunities where we can learn about things about Kafka. So let's get to this one a little quick. So this is what we were announcing for the next week. Apparently, previous the workshop when I was doing the Spring Boot and the Confluent Cloud, apparently it was a huge success because I've seen the many views, people who watched this live. It was extremely humbling to see like so many people join and who were interested to learn stuff from me. So it was great, and we got some requests from folks around like, so we should continue to do this. And I was thinking, okay, so it's a holiday season, so we started with the Halloween, so we skipped the Thanksgiving because I was on a vacation, and now it's going into Christmas and New Year time. If you're not celebrating Christmas, it's also fine. I'm really celebrating the New Year. So we're going to be doing this the Christmas special, and in this workshop we will continue to do stuff, but this is going to be hands-on. So if you do like live streams, just like as a second screen experience, for example, you're sitting here and you would be the watching stuff that happening on my screen. This one would be more hands-on experience where you will be able to participate. If you've seen the previous workshop, you pretty much know what to expect. I need only one thing from you. I need you folks to RSVP, and I need this in order to generate this the coupon code for Confluent Cloud. So you will get like a $200 something discount. So you will be able to run the workshop for free. So in this workshop, we're going to be focusing on, again, the infrastructure side of things would be in Confluent Cloud, and we'll expand how we can deploy some of the Kafka streams into Kubernetes. We're going to be using Spring Boot. We're going to be using some of the things that I already kind of showed here or like highlighted somehow, but it's going to be like a step-by-step run through of all these things. So give me please the favor, just like go and sign up. So let's see what people are saying in the chat. So it was great that we have Sergey from Toronto, welcome. Welcome, it was great to be here. Kartik from Texas, great to be here. Great that you're here. So yes, we just post this link into YouTube chat. So if you go and register, that would be great. So next thing is this week. Actually, if you have not enough me this week, I will be doing the webinar with my friends from JetBrains. And many of you know that JetBrains, they developed my favorite tools. They develop things around development, IntelliJ, WebStorm, and some of the other tools for other languages. And this week, December 10th, just in a Thursday, I will be doing a webinar with my friend Anton from JetBrains. And we're going to be talking about the Kotlin and Kafka. So if you are probably, if you're in these live streams, you're already familiar with Kafka. If you're not, familiar with Kafka, you can also join this because it's designed to be for people who don't know Kafka at all. And we will make the aspect of Kotlin programming for Kafka, like what libraries you should use and what tools and in general, like if you Kotlin developer want to learn a bit more about some of the alternative languages, I highly recommend to also sign up to this webinar. It's gonna be great. It's not gonna be your typical webinar. We're gonna be doing some cool stuff around like live coding and some of the slides, maybe less slides, more live coding. So if you like live streams, you're gonna enjoy this as well. All right. So as a reminder, I will switch to, for those of you who join us for the first time, and when the people are asking, so like where I can find all this, the source code for all this material, everything that I'm talking about will be here. There's a repository on the GitHub, Confluent/demo scene, and you will understand that you're in the right place if you see this fancy ASCII art logo courtesy of Robin Moffat. He's our ASCII artist, no pun intended. And there's a folder of live streams, and every live stream that happened will have the folder there, and you can find the source code, all artifacts that happened there. All right. And so last time we touched this. We were talking about some of the deployments, and I think this is the time to, for us to refresh it. So while I will doing this, let me quickly, I will create my cluster for live streams, and while I will be creating this cluster, we can talk about some other things and things around this demo. So the last time I wanted to show you I wanted to show you one of the patterns, interesting patterns that you can apply in your development. If you've been here, you already kind of like familiar what I'm going to be talking about. But for those of you who missed that, hopefully we have some new people, fresh blood in the channel. So I was talking about the Kafka Streams and how you can write microservices using Kafka Streams. Previously, just let me quickly bring a presentation mode. I'm going out of this and I'm moving it here. So you should be able to see this screen. Also, I'm trying something new today. I was a huge fan of the dark theme, but recently on some of the presentations that I did in the conference, people tell me that like a white might be looking better on the screen versus black looks better when you're presenting on the projector. So let me know in the comments if you feel that the size and the colors of this is better when it's in white versus when it's in black, or like a black and white and white and black. All right, so while you're commenting, I will just briefly explain what we're trying to do here. So I wanted to show you some couple things in this cycle, like with the things what I was doing this for a couple episodes, and you can go and find those episodes in YouTube, and there's a playlist where you can find all videos that I did on this subject. So, and I wanted to show you how we can write the microservice, how you can do something useful with this microservice. And I start with small use case that some people commented and they were interested in this use case. So this use case was around the materialized view. So essentially how you can do this, how you can get something from the Kafka topic and access this by key. Usually when we're talking about Kafka, we're saying when data is in Kafka, you cannot access this data randomly, you cannot access this by key. But with this microservice, I want to show you how we can quickly implement something that allows you to have access to some of the data that stores in your Kafka topic and will be accessed this by key. So in this case, this application is very simple. It has let's actually instead of talking, let me show you. So that's what we were doing here. So the orders applications is relatively simple. This is my application that will be reading data from orders topic. That will include some of the information that service that's responsible for creating online orders will be pushing into my Kafka topic. Now, in order to make this a materialized view, I'm using this the API called table. So my string builder creates a table, and also this table would be materialized as order store. Why we need to do this? I also want to provide access to this store through thing called interactive queries. Interactive queries is the way how you can get access to underlying store. So this is the simple implementation, super primitive, and maybe doesn't work exactly as we expect because it requires some other things to enable like distributed mode. We will talk about this hopefully later today. I will start talking about this, and we'll finish about this maybe the live stream after next week, because I want to show you how you can build the microservice that also will be kind of your distributed database, and we'll bring some cool technologies like gRPC maybe, or RSocket or something like that. So something like this. So essentially, this is application, and this application also includes some simple producer. So what we expect when we have some data in our topic based on certain key, I'm placing two orders, and the table will contain latest and greatest results. So what I expect is that instead of for key 1, I always have an iPad and AirPods, and for key 2, I'll have a HomePod. The way how I usually validate this, if you just join us today for the first time, I like to write a test for with the framework called topology test driver. So topology test driver allows me to test the logic of my application without running this application. So in this case, I would this is my logic. I'm creating this input topic, pushing some data into this input topic, and after that, topology test driver allows me to get access to data through state store. Remember the when I click here, I'm sorry, this one. When I created this state store, materialized as, that will create it a state store underline. So, and after that, that should work. So let me quickly run to show you that this is actually works. And it doesn't run, it doesn't have anything to do with like running Kafka infrastructure. So that should be it. All right, folks. Nice. Let's see. No such method. Topology builder. Interesting. Maybe I do messed up with some of the dependencies. Let me see if my my dependency are on point, as if I may say. So we're using. That's correct. I'm not sure if Spring Boot in version that I use uses exactly version of this. So I would go and Spring Kafka test. And also I need to include this library. Okay, so here's the thing. I'm using the Confluent packaged version of Kafka Streams. It does have certain differences that we will discuss in a second, just like technically just one thing. But so what we're looking at, we're talking about, so in this case, we do need to have a method that will, dependency, where is it? Dependency. Streams test utils. Streams, Kafka Streams test utils. Utils, do refresh. This jar file will include our topology test driver, and if I would run this, that should work now, hopefully. Fingers crossed. Here we go. So what has happened, because the different jar was in a class path from version 6 versus version 2.5, it clashed with some of the things. Now, the logic of my topology works. So let's talk Kubernetes now. So in the previous previous episodes, I showed you this cool tool that I use called Skaffold. So Skaffold is a open source tool that allows you to kind of like organize your build process of your images and do some of the testing, some deployment. We didn't explore some of the debugging aspects, which is also pretty cool for my application. But essentially, in this config, I will be using the build packs to build my image for this Docker. And after that, when I will be deploying this or test running those, I will be using this two manifests. One manifest will be responsible for deployment itself. And one of the things that we're going to be looking at is to deploy some of the configuration for Kafka Streams. And another one is configuration for the stream state store. So the state store will have a local persistency. So this guy, when we're talking about the, let me do it bigger. So, so this guy, this state store will have its own place in this pod. And in order this to make sense for my application, I also creating this deployment not as a regular deployment or as a replica set, I'm creating as a stateful set. Meaning that if my application will go down and will be rescheduled in another place, in another node, this state store will be reattached back to this application, back to this pod. So in this case, some of the local state do not need to be reread or recalculated and rehydrated from Kafka topic. So that's pretty useful thing to have. Now, as always, we do have this application secret in order to connect to our Confluent Cloud, to my Confluent Cloud. You can get your own Confluent Cloud. Get your own Confluent Cloud. Go do it now. So meanwhile, I don't see any questions. Folks, let me know if everything is clear. You got the idea. Maybe you have some other questions. Remember, live streams is not only about me talking about stuff that I'm interested in, but I also encourage you to ask questions that you would be interested in. So this is how you can influence some of the content creation for the show. Remember, I told you that some of the things that I'm doing came as early comments in the previous show. So streams, live streams. So I will create this cluster and I'll show you what I'm doing here exactly. So again, reason why I'm showing this every time, creating cluster is super easy and super fast. I don't need to even worry about this. I would just run it, and you also can do it yourself. And as a Spring tool, let me quickly create a key, and I'll say create a key. Just copy and copy. And I'll have it live streams. And click save. And if I go to client and tools and go clients, and in the clients there's always Spring Boot section. You can go there and just copy this one. So in order this to work, we go in here. Be careful with YAML. And only thing that we need to change here. This stuff, right? So let's see. We do this. So this is our cluster key. My key. This is how it looked like. Do not steal my secrets, please, friends. Do not copy paste this. Now, schema registry. I don't need this as of right now, so we can remove this. So we don't need this. Plain, this is my Kafka cluster connection. This is my Jazz config. This is my Kafka template. And it's good to go, I think. We'll see. We will run this and see if we can investigate this problem in this in this setting. All right. Meanwhile, let's take a look on some questions. So, Abnuzal is absolute beginner and he doesn't know where to start. I think I would expect someone from the chat and community will answer this for me, but hey, developer.confluent.io. Developer.confluent.io. Go there. That's the place where to start. If you're absolute beginner, we have a last week we just released, or like 2 weeks ago, I don't remember. So we just released incredible content for beginner. It's video. If you like videos, hopefully you like videos if you're in this live stream and you're watching me. There is a kind of like a blog style thing that explains what the Kafka is and like how to connect all things around this. And there's a bunch of different links. So go there, developer.confluent.io. All right, cool. So the Skaffold, is Skaffold equals to Helm and how it is different? So that's a good question. So Helm, it is a tool that allows you to package your Kubernetes application into something that they call releases, and you can manage these releases lifecycle. They're providing templating and all these kind of things. So Helm is a more higher level thing that allows you to establish like artifacts management and supply your application as a one big thing with like all these kind of resources. Skaffold doesn't have this kind of like templatization, but as far as I can tell, Skaffold can work together with Helm. So if I go and quickly Google this for you, Helm and Skaffold. And Skaffold supports packaging of Helm as one of the steps of the pipeline, of the development pipeline. So in this case, you can use the Helm together with Skaffold. Maybe we should look at this one in one of the future episodes. It's a very good question. That's a very good question. Thank you so much for this question. Now, yes, so the repository is on the live streams, and I will ask my my friends and colleagues to send these. Or if you go to any video in the live streams on YouTube, you can find there is a show notes. Inside the show notes, you can find pointers to all these repositories. You can find it there, so it's there. All right, so Confluent operator successfully deployed. In running cluster, if you want to modify some property parameters, how we can change it by using Helm command. Example, suppose I want to change parameter from auto create topics enabled to auto creates enabled true, where I should change it. So you do, first of all, you're not running install again, you're running the upgrade command, and with upgrade command, you're changing this value into updated value that you want to change. So the way how you can do this, there's like a shortcut. You can always go and modify something in the Kubernetes side of things if you want to change some parameters. In operator world, you want to change some of the resources somehow in order to operator to react on those changes. If you're changing some of the configuration, it needs to, I don't know, like rebalance the cluster nodes and things like that. So you need to run the Helm upgrade command to do so. We're working on the updated version, the very soon. It's probably already there. Is it there? Is it there? Yeah. So like the people saying it's there. It's already if you go to our YouTube channel, you'll find a video where I'm doing demo of the new version of Operator that doesn't require Helm, and we just open this kind of like a public early access. Everyone can join in. All right. All right, cool. So yeah, that's maybe a Helm topic would be an interesting discussion for the future episode. So we'll see how it goes. Now, into my application. No. All right, so I'll do a scaffold. Okay, so I need to save this alias. In this case, it will be faster. So here's the thing. Docker is not running. This is what I do in order to prevent the high resource utilization if some of the Docker images are running. So let's see. It will take some time to do. It's still not up. Let's see if we have any other questions meanwhile. All right. Okay, there's a question about liveness and readiness probes for Kafka Streams application, if there's some best practices. Yes, I don't have it in this version of this application, but essentially there's a couple interesting things that you can do. So first of all, since I'm running this inside the Spring Boot, and Spring Boot manages my Kafka application, and it will make sure that when the application will start, it will check this Kafka Streams bean will be fully available. So if we will be using some of the actuator thing from the Spring Boot, we will be able to use this with Kafka Streams applications, and you can enable this as a liveness probe. In terms of like readiness and making sure that your application is up and running, there's a couple interesting things that we will discuss. This is a very good question that puts me into very good topic that we can discuss. So there is a API available in Kafka Streams. Let's do this one. It's called something state change listener. 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 I don't remember exact name. State. State listener in Kafka Streams. So state listener in Kafka Streams allows me to define my own state listener. Where is it? Not this one. Not this one. I'm looking for something. Stream state listener implements state listener. Let's see if it's public interface. Public interface. I can do this. So on change, I will get the new state, and I will have a small probe that will expose if my application is in running state. So in this case, we can say it's alive, it's working. If it's not in a running state, meaning that it's dead, it needs to be rescheduled. So this is a very good question. Expect the follow-up live streams where I will break this down. Let's see if there's other questions. Helm 3 can do this kind of pattern or sub GitHub repo for stream upgrade and delete alt. Yeah, and Helm 2 also was able to do that. So that's both things that you can do with Helm. It was like there for a while. So thanks for this. Now let's see if my Docker is here. So why I need to Docker? Why I need to have a Docker here in my in this application? So I need Docker here just because I am using Docker daemon and Docker client to build my images locally. So when I do this scar run, my scaffold will check if there's image available for this application, and if it requires to build and requires to verify. So apparently, so what I see right now. There's plenty of things that my application doing, and it looks like there's not much is available. Plus, it uses special type of utility that will build my image. It will use build pack, and build pack depend on the tool called builder in order to build a image from this Java application. And it's always recommended ways to use the build packs with Spring Boot. And if you're running this Spring Boot with boot image run, there's a like automatic build pack built in as a part of Gradle plugin. So in my application, in my Skaffold config, I just specified this that I'm going to be using this. Oh, sorry. Where is it? Yes, this is my builder that I will be using. This is my build packs, and this is what builder I want to use. So this is what I'm going to be using to build my image. Now it takes some time to build this once again, so we will we'll see how it goes. Yeah, it's great. I'm just saying that it's great that we start seeing some of the conversation among the listeners, people who watch this, and also trying to help some other listeners to figure something out. All right, so while we're waiting, so let's talk a little bit about some questions again. While we're building this stuff, so we can use something as you know, is some of the conversation builder. If you want to, okay, so that's what is happening. So some of the additional layers would be placed on this image in order this build pack to work. And the next time when I need to rebuild this, it will only rebuild the top layer of my application. That will include only changes that came from the code that I modified. Like all underlying infrastructure, including some of the dependencies, some of the Java version, operating system layer, all things will be captured by this tool. It's very similar to whatever Docker does. So because underneath they're using Docker image. So still building, and it's very interesting to see how the computer starts spinning while my Docker builds our images. That's pretty cool. Let's see, we're still building. Yep, application now created in the local cache. Next thing is that secret was created and stateful set was created. So let's take a look. What do we have here? So I connected to this application into. Let's see if we will have any interesting logs so far. So far it's creating a container in my Kubernetes cluster, and we're waiting for some of the response, waiting to see if there's anything appeared. Let's take a look on first some of the things first. Okay, let's take a look. So okay, get secrets. Okay. Get secret. So my application, Spring Boot application properties was created here as a part of the secret that will include connection to my Kubernetes cluster. And okay, GA. So let's see if my application container creating. It stuck somewhere in container creating. So now first application is up and running. So let's take a look what's going on inside. Now, both applications are running. So let's take a look on the output of the first application. Application successfully connected. So let's take a quick look if we will see some of the good sign that application is up and running. Where's the how I can turn on wrap? Yep. So I can see the word wrapping. Application. What we're looking is something around application is running. Version of Kafka Streams, Confluent Platform 6, all good. Now, let me do this first. Let's start this. We just I start a little bit too hot, and in this case I will do replicas 1. And I'll do and I'll do I will do k scale stateful set and replicas 1. We'll start with 1 just to and let me open this guy here, so I will have this open time to time when we're switching. So it will kill this one. We'll start from scratch, and I will explain a couple interesting things here. All right. Yes, okay, Gabriel. As I said, there is a very useful tool called a YouTube playlist, and there's other videos that have a link to this one. So essentially, this is where I want to go. You want to go to Confluent Demo Scene Livestreams. This is where all the code here, just a bookmark it. Go here and start this repository. So be the person who appreciate work of our teammates. And the November 17th will include all the code. So go there. Now let's talk about some interesting things that I want to show you. So my application is let's see. In running state. So this is application is up and running. So I will be able to get some information in my Confluent Cloud. Let's see. I have a data flow topics ordered messages, and let's see if we have some data. Let's do reset offsets from 0. My orders data just landed here. It's already here, so we have some data here. Now, how we can hit this one? Now, in my application, I also have this IQ controller that will be exposed through IQ and ID. So I can hit this URL to get some access to some underlying data. And the way how it's configured, if I go to deployment, I will be able to do things around, container port 8080. So I potentially can do port forwarding. Let's see how we can do a port forwarding here. We can do container port local port 8080. Okay, sounds like a good plan. So port forwarding is activated. If I will go here and I just do HTTP 8080 IQ/1. So now I return all the messages for this iPod. If I do 2, it should be HomePod. So my API works, application works, all great. So let's also explore one things here. If we can do a shell, let's do shell. Let's go inside here and see what do we have here. And specifically what we are interested in, let me put this here. So specifically what I'm interested in this folder. So it's called MNT Kafka Streams store. So if I'll go here, MNT Kafka Streams store. So what I will see here, I'll see orders materialized view. So for each application that runs the Kafka Streams, there will be created a folder that will include state store. That's what we configured here in our application.properties, our secret that includes this. So Kafka Streams properties state dear MNT Kafka state store. What do we have here? For each partition that we have in our topic here, for each topic here, let's see configuration. We have 6 partitions. Kafka Stream create for each partition in this topic, Kafka Streams will create a task. Each task will own its own state store. So the state store will be stored inside this directory. So like if I go here, say 0_0, and we'll see what we do have here. There's some RocksDB and order store. So this is going to be my binaries from my application. So this is where Kafka Streams stores all your intermediate state of your application. Now, as you can see here, now all my, since I'm running this one instance, Kafka Streams right now, instance of this Kafka Streams application is running 6 tasks. Each task has its own state store, and all this kind of thing will be available. Where is it? Will be available in these directories. Now, so once we're done with this, now we can scale this and see how this picture will change. Specifically, how this picture will change. Let me show you one last thing that you will see here. So this is what we see. This instance of this application will own those tasks, and this task will be running. And also, it has some information from existing tasks, because I started this not from the very beginning. I started with 2, so it already kind of like a parallelize some of the workload. So let's see how this will change if I would do things like do scale, and I'll do 2, and we will just simply we'll be watching this in the auto scroll. Auto scroll S. Yep. So we will be able to see. So I started new instance of my application. Now it will join my consumer group of my application, and Kafka Streams will figure out how to deal with this one. So now my application back to running state before it was in rebalance state. So it's switched to from running to partition assigned, from running to rebalanced, and after that it's back to running. So now its application is in running state, and now we can see this instance of application owning only 3 tasks, because the other applications will own the rest of the work. Now, if I will look into this one, into this application, and what we will find is that this application should have different tasks that it owns, 0, 2, 4, just simple. Now, let's see if we still will be able to read our data. So I'm hitting, remember, right now my 8080 port is pointing to 8080 port inside my first instance of application. So I'm hit 1, I get the empty answer. I'm hit 2, I get the answer 2. Meaning, during this rebalance, state store that has all this data was migrated to another instance of my application. So if I would do something like this, if I will do and set the port forwarding for this one, I'll just do Shift F, and I would say local 81. So now I will be able to go here and say IQ1, and it will be able to hit this instance that owns it. That's not very convenient. That's not very convenient for our application to do API, because we need to know the ports and things like that. We will fix that. But before that, let me see some comments here. All right. Let's see some comments. When does it make sense to use HPA from Kubernetes in orders to scale up and down according to your load, considering rebalancing that would be triggered? That's a good question. That's a very good question and very interesting question. I would be interesting to explore this, but in general recommendation, those horizontal pod autoscaler capabilities, they need to feed with some data that's relevant to our application. What kind of information would be relevant for our application? For example, if our application consumer lag is growing and growing like significantly, we feel that, okay, our application maybe not be able to handle all this load immediately. So what we will do in this case, we will just create this autoscale rule and say, like, if our lag would be some ridiculously high, start another instance of my application. In this case, Kafka Streams application will join and will continue to do, or maybe you can just join 3 more. But there's a catch. There's a small catch here. Specifically, it depends on also number of partitions. So you cannot run more instances of your Kafka Streams application than than like number of the number of the things that the number of partitions that you have, right? So, but that's a great questions, and that's something that I would love to explore. Stay tuned, and don't forget to subscribe, and you know the drill. If two instances when each handles 3 partition. Yes, exactly. So that's what I said. So my application right now is running. So let's take a look on. It's a good thing that I don't need to do hand waving to explain this, because there is a fantastic feature of the Confluent Cloud that called data flow. That let me quickly switch and show you what I'm talking about. So if I go to my Confluent Cloud cluster overview, and I'll show you data flow. So data flow actually has a couple things. So this is my producer application, but we are interested in our orders topic, and we're interested in our, where's that, our consumer? Where's our orders? Visual partitions. Can we see what kind of consumers? No, I think we need to go in consumers. That's my consumer group, materialized view, and each consumer will be assigned to particular. Each consumer will be applied to any instances of my application. So it's weird, because my partition 5 at 0 shows me topic orders. Yes, so that should show me a few more. So some of the information is missing. I need to investigate here, because there should be some more consumers also available for my application, because it doesn't add up. I will check that for you. But always, if you will be looking to logs, you should be able to know which task owns particular partition. So you would know that's like if I will run this, what's going to happen? What's going to happen if I will run one more? So let's take a look on if I will run this. Say, let's go and continue to observe here, and I run the scale again. If I will do scale with replicas 3, and how this picture will change when I edit this new when I edit new pod with Kafka Streams application. Let's see. Okay, it's starting. It's pending. Oh, that's very interesting. This is pending. Why it is pending? And here's the problem with this pending. So can I go and hit my IQ? Still can. And the reason for that, because like when it's pending, it's still not it didn't join this, and it's a limitation that sits on the side of Kubernetes. It's pending. Why it's pending? So let's see if we can see from this UI if we can see some of the events. No, we can't. So let's see. FL2K events. Get events. So, and what is going on here? Why it is pending? We see normal warning. I don't want to like keep this intrigue for a very long time, because we're going very close to the end of the hour. But one of the things that I already have configured here in my deployment, as you can see here, there should be something called pod affinity. So current setup is configured for my stateful set is that my node in my Kubernetes cluster, as a reminder, I can get nodes. I have only 2 nodes, and I have 2 pods running. Since I have this pod affinity configured, it says that I will not be able to schedule anything on the same node. So since I have 2 nodes, I already have 3 replicas of my, or 2 replicas of my application. I will not be able to add another thing here. So what I can do here, I can run this like a scale command for gcloud scale and or not scale, sorry, resize. Scale it as Kubernetes. Resize, and it's here. So when I increase number of nodes, yes. So watch what's gonna happen if I will do. As soon as my node would be added to this cluster, to this Kubernetes cluster, I will see that my application would be scheduled there. So my Kafka Streams application would be scheduled there. So while we're watching, I would also take a look on some of the comments. I want to also show the comments, but I also want to show you this the screen also. So we will. Okay, so we just added new node. Node is, so if I'll do get nodes, a node just joined the cluster, and we should be able to see this state will change in a few seconds. See, now in business, container creating and all this kind of like a cool jazz. So we're gonna be seeing all this like running numbers and things is going up and down, up hopefully, and all these partitions will be rebalanced. Now, so once we will done with this in a few seconds, I would like to kind of explain what we're going to be seeing the next time, because we're close to the top of the hour. So application is running, nice Spring Boot logo we still have here. In a few seconds, we will see that application join my consumer group. And now it should switch to running, and we should see number of tasks that this application is running. Now it's a 2 task. We have six partitions. We have 3 applications, and each application runs 2 tasks that will serve each individual partition. Now, here's another problem that you might be expecting. So if I will run this, probably because I killed the instance of this application, so it also killed my port forwarding. So let's do this once again, real quick. Port forwarding, it's 8080, and for this one I will do 8081. And let's take a look if I have HTTP 1, and I would say 2. It's not there, so it's supposed to be here, right, in 8080. It's still there. So because of the Kafka Streams is smart enough to not like just move things around, and it knows that there's some data is available in one particular node, it will not just move this off the bat. But still, like this is not cool thing to do. You know, having this. Knowing in which node has your data. We will fix that in the next episode. So now, before I go, I would like to answer some of the questions that I have here in my YouTube chat. So how to configure cluster based on the Helm chart by using custom Docker image. So your custom Docker image should be placed in some Docker registry. And in order to access this Docker registry, your deployment should have access there. Usually it's solved by having sort of secret configured inside your Kubernetes cluster that will have like an API key that will allow to Kubernetes cluster to read this in read the secret and will be able to connect to your external Docker registry. So you cannot just put the arbitrary Docker image inside your Kubernetes cluster. You need to put this in your Docker registry somehow. It can be Docker registry that provided by your Kubernetes cluster, or it can be things like Artifactory that will be your custom registry. I hope image already normalized, and hopefully, you know, you will see the nice and sharp and clean image now. If operator port itself killed, what will happen? How to handle this exception? So usually this pod will be handled, you know, you need to, pod itself needs to be rescheduled somehow. If you create a deployment, it will be rescheduled automatically. And nothing would happen from perspective of application. Application should continue to work, but there would be some problems in terms of who will serve these custom resources that operator will handle. Okay. Yes, we have a multiple consumer group. Would it make sense to use stateful set instead deployments for a big stateful Kafka Streams application in Kubernetes and mount the volume and the RocksDB data? This is exactly what I'm showing to you, my dear friend, that look like a young Steve Jobs. And that's, hopefully it's, yeah, there's 8088. Yes, that's exactly what I'm showing to you right now. I think it also depends on the size of the state and what kind of problems you're trying to solve. If you're trying to solve the problem of the you know, fast startup and your application don't want to wait until this data will be available through the Kafka topic, maybe it's a good sense. Maybe it's a good case. But there's another thing is that even though you don't have the stateful store, let me show this one. Even though if you don't have this, even though if you might not have your stateful set configured, you're using just deployment, and you also not have a custom state store configuration, the Kafka Streams get you covered. The way how it's done, the topic and the data information would be placed inside this state store changelog topic. So if my application will start in the pod where there was no previous state in file system or there was no mount and things like that, this state will be recovered from the changelog topic and application will continue to work. So I hope it makes sense. I hope it makes sense. Yes, I did notice Steve Jobs here. Folks, it was a blast today. I have such a great time. Next week, do not forget, next week, sign up. Let me know how many people of you will be there so I will prepare appropriate number of licenses, or not licenses, the coupon code, so you can also play around with Confluent Cloud. So go there, a link in the description in this chat. We also will put this into, how you call it, show notes in the description under this video. You can find this right after we will finish. It's gonna happen next week, so it's gonna be more like a workshop. You can, you know, I will showing you and you will be executing commands and things will magically work. If you want to know how this will work in general, how the Kafka Streams application work and all these nice bits around the cloud and things like that, do not forget to subscribe. I will see every one of you hopefully next week. My name is Viktor Gamov, and as always, have a nice day.